Okay, we can go ahead and get started with the last section of the semester, the endocrine system. So, just a couple objectives as usual. We'll talk about the general functions of the endocrine system. We're going to differentiate between the couple different classes of hormones that are important to the endocrine system. We'll identify the role of the hypothalamus, the major endocrine gland in the endocrine system. And we'll describe the functions and effects of hyposecretion and hypersecretion of different hormones and the effects on the body that has. And then we'll lastly discuss the endocrine system's response to stress and how that pertains to physiology. So, general functions of the endocrine system include producing hormones and then releasing them, secreting them to affect different areas of the body, and those different areas can be involved in reproduction, growth and development, maintenance of electrolytes, water, nutrient balance in the blood. This will usually be targeting the kidney or maybe the adrenal glands or the liver. Regulation of cellular metabolism, this will be involved in the adrenal gland as well, and mobilization of body defenses. So the immune system, we got to be able to move those immune cells around, so we're going to be immobilizing those somehow, and that'll be through the thymus. So a couple different classes of hormones we can discuss. We have amine hormones, which are derived from a modification of single amino acids, either tryptophan or tyrosine. And different amine hormones include melatonin, epinephrine, dopamine, and there's other ones as well. And then there's peptide and protein hormones, which are multiple amino acids linked together to form a chain. Peptide hormones are really small chains, whereas protein hormones are really long chains of peptides together. Different peptide or protein hormones could be like ADH, growth hormone, or follicular stimulating hormone. Then steroid hormones are going to be derived from cholesterol, which is a lipid. So we have testosterone, aldosterone, estrogen, progesterone. Those are all derived from cholesterol. And a key distinction between amine hormones, peptide and protein hormones from steroid hormones will be that the first two classes are water soluble, so they degrade very quickly in the bloodstream. They'll solubilize in the blood. Very short half-lives, which means that they don't last very long. So they are usually released really close to their target organ. Whereas steroid hormones can travel long distance and degrade slowly because they are lipid soluble. So they can hang out in fat tissue. They can also just travel long distance in the body before they reach their target organ. So starting off with the hypothalamus, this is nervous tissue. It connects to the pituitary gland. The hypothalamus itself synthesizes a couple different hormones. Some of those are stored in the posterior pituitary until the hypothalamus stimulates that gland to release those hormones. The hypothalamus also synthesizes hormones that stimulate the release of other hormones that are made in the anterior pituitary gland. And then the hormones from the pituitary are going to cause changes via chemical signaling throughout the body. And so you can think of this hypothalamus as the master regulator of the endocrine system. It's the starting point and the ending point for all negative and positive feedback cycles that are going to be controlling hormone output and their effects on the rest of the body. So you can see the hypothalamus is this little area of the brain snugged underneath the thalamus, and there's these glandular lobules that extend from the hypothalamus via this infundibulum. There are two different glands on this. Technically, it's just one big pituitary gland, but it is divided. And on one side, you have the anterior pituitary, which is simply glandular. It's an endocrine gland. And then on the other side, we have a posterior pituitary. And really, we can just call the posterior pituitary just that. It's not really a gland. It's a storage apparatus for hormones that the hypothalamus releases. So the posterior pituitary is a nervous tissue. So there's these nerve tracts that stimulate the release of these hormones. And the two hormones are antidiuretic hormone and oxytocin. Oxytocin will go on to stimulate uterine contractions to initiate labor, also causing milk ejection in lactating women. Not the production, just the ejection. And then also oxytocin is released in the sexual response for orgasms in women. Antidiuretic hormone, we learned about this when we talked about our urinary system, is going to stimulate kidney tubules to reabsorb water. And along with that, some salt usually will follow, but in general, this hormone is inhibited by alcohol. So having alcohol in your system makes you end up pee more because it isn't, this ADH is not stimulating water to be taken up in your kidneys, and so that water just goes through you faster, so it dehydrates you. So you got to make sure you're always drinking water when you're taking alcohol in as well, so you stay hydrated. The other pituitary is the anterior pituitary gland. Okay, so this is a solely glandular or endocrine organ. Produces and secretes hormones. So unlike the posterior pituitary, which only stores hormones that the hypothalamus produces, the anterior pituitary makes its own hormones. And upon stimulation by the hypothalamus, it releases those hormones. There are a few different hormones that it makes. It will stimulate the thyroid with thyroid stimulating hormone, stimulate the gonads with follicle stimulating hormone and luteinizing hormone. It will stimulate the adrenal glands, which are tucked on top of the kidneys, with adrenocorticotropin hormone. And then it'll stimulate the mammary glands in women for prolactase. And then stimulate general somatic cells, like body cells, with growth hormone. So a lot of different hormones involved here. So we're going to start talking about hormone actions and their targets by the hypothalamus and the anterior pituitary now. So starting off with the hypothalamus, on this column over here we have all the hormones that the hypothalamus produces. This column is the target site of that hormone, and this is the effect of that hormone. All right, so the first 5 up here we have are going to be targeting the anterior pituitary, and the bottom 2 will target the posterior pituitary. So the gonadotropin releasing hormone will stimulate the anterior pituitary to release FSH and LH, which will go on to stimulate the gonads. So gonadotropin releasing, so it's going to stimulate the release of gonadotropics, so FSH and LH. Prolactin releasing hormone will literally go and make prolactin release from the anterior pituitary. So that's exactly what it does. Prolactin goes on to stimulate mammary gland production of milk. Thyrotropin releasing hormone, this is going to act on the anterior pituitary as well, and this thyrotropin releasing hormone is going to stimulate the release of TSH, not TRH, TSH. So this is thyroid stimulating hormone, and it's going to go on to do exactly that, stimulate the thyroid. Corticotropin releasing hormone releases adrenocorticotropic hormone from the anterior pituitary. And then growth hormone releasing hormone, GHRH, will go on to stimulate the release of growth hormone from the anterior pituitary. And then we already covered antidiuretic hormone and oxytocin. Those are produced in the hypothalamus and go on to be stored in the posterior pituitary until they're released by the hypothalamus, stimulating it, and they go on to stimulate water reabsorption in the kidneys, or in the case of oxytocin, stimulate uterine contractions during childbirth, as well as the other functions we just mentioned. So the anterior pituitary, like we said, produces these different hormones that we just covered on the last slide. They're all in acronyms now. If you need to see them spelled out, go back. But FSH and LH are going to target the gonads and will stimulate gamete production and androgen production, like we just talked about in the reproductive systems. TSH is thyroid stimulating hormone. It will go target the thyroid, and it will stimulate release of thyroid hormone. Growth hormone goes on to stimulate the thyroid. It will promote growth of body tissues, and so the thyroid isn't the only target of this growth hormone. A bunch of different areas in the body are targeted to go be stimulating growth of different tissues by growth hormone. Adrenocorticotropic hormone is going to stimulate the adrenal cortex, and this will stimulate hormone release from that cortex. And then prolactin goes on to stimulate the breasts to produce milk in the mammary glands. And so this is those anterior pituitary hormones. The thyroid gland is found near around the Adam's apple in men, or just snugged underneath the thyroid cartilage in men and women. It secretes thyroid hormone upon stimulation of that TSH, the thyroid stimulating hormone. So then it releases this thyroid hormone. This thyroid hormone is predominantly this thyroxine form, this T4. It goes on to increase metabolic rate, which will basically bind to receptors in mitochondria, prompting them to increase nutrient breakdown and use oxygen to produce ATP. And this means that more heat is going to be produced as a byproduct of exothermic chemical reactions. So people with overactive thyroids can run hotter than normal, which can affect many different aspects of human physiology, as well as reproductive functions. So you see that down here as well. So blood pressure is also as a part of that, and child tissue growth and development are crucial aspects of this thyroid hormone being at a regular rate. Calcitonin is another hormone produced by the thyroid. We talked about this in our skeletal system lecture. This helps lower blood calcium levels by inhibiting osteoclast activity. So those osteoclasts are going to be releasing calcium into the bloodstream, and this will help lower that calcium level in the bloodstream by stopping the osteoclasts from doing that. So hypo or hyperthyroidism are functions of over or underactive thyroid glands. So hypothyroidism is an underactive thyroid based on abnormally low levels of thyroid hormone, or T4, thyroxine, in blood. This leads to low metabolic rate, weight gain, cold extremities, reduced libido. So everything that we said on the last slide regarding the functions of thyroid hormone will be in flux because of not having enough of it. Same thing goes for if we have too much of it. We'll have abnormally high levels of thyroid hormone in the blood, usually caused by like a tumor in the pituitary gland causing overactivity. This could also be the other side of things, a tumor in there causing hypothyroidism. But hyperthyroidism is typically caused by a pituitary tumor. This will increase metabolic rate, excessive body heat, sweating, weight loss, increased heart rate. Can be really scary for certain individuals that have severe hyperthyroidism because it's very difficult for them to gain weight and cool off.